Okay. So today we're going to look at factoring with the greatest common factor. With the greatest common factor. Okay, or greatest common factor is, we call that GCF for short. All right. So again, this is stuff that you've maybe seen before or you've hit on before. Okay. So before we get into like what the greatest common factor is, let's just talk more about just what it means to factor something. Okay. To factor something, well, does anyone have an idea what it means to factor something? To factor like a number or something?
It's that tree thing.
Okay, so we have a factor tree that we use. Yeah, Julio? Separate the number. Okay, separate it. How do we separate it, though? There's lots of ways we can think about separating the number. What operation do we use? Division. Okay, Jay, did you have something you wanted to add to? Okay, in a way, no, it does involve some sort of simplification. It depends on like what you're trying to do, but sometimes, yes, factoring is a way of simplifying something. So, yeah, absolutely. Very good. Okay, so a factor, okay, is basically a something that evenly divides a monomial or a polynomial.
Is a polynomial two?
A polynomial, yes, two or more. Okay, so what that basically means is like it, you know, if I have a number, okay, a factor of a number is just something that evenly divides that number. Okay, if I have something with like a number in x's and y's, it's something that evenly divides that number with the x's and the y's. Okay, so just as a quick example, okay, so we'll list some factors of the given, you know, I don't know, numbers. Okay. Yeah, we'll list some factors of the given numbers. That's what we'll do, okay? So just as an example here. All right, so for example, let's look at like 12. Okay, what are some factors of 12? Okay, so yeah, 6. Just shout out 2, 3, and 4. Anything else? 12 divides 12 evenly, right? And then?
1.
Yeah, and then 1. Or any more?
No.
Yeah, no, that's it, okay? So these are the factors, okay? What's that? Exactly right. It's only whole numbers. Yeah, it's only whole numbers is what I should have said there, okay? For the numbers at least. So those are factors. We could look at, let's see here, what about, let's look at like 14xy. Now what are the factors of something like 14xy? What would divide that evenly? Okay, so 14 would? 7, 1. 2.
It's the same thing, just without the x and y. Like, is the x and y relevant?
Well, it's a good question here. What else could we divide this by evenly? X and y.
What about 14xy?
And 14xy and xy together, or 2xy and 7xy, all those things. Yeah, you can see here there's lots of options when you throw in those. Okay, all of those things would evenly divide that 14xy. Okay. What about something like, now let me get a little bit more crazy here. What about like 7x squared?
7.
So, right, so 7, 1, 7x would divide that. What's that? 49? No, 49 would not, because 7 divided by 49, it wouldn't simplify.
7x.
And then 7x squared. And then, yeah, just plain x squared would divide it, and there's one more. X, yes. Okay, all of those things divide these two things. Okay? Now, what we're going to then talk about, well, actually, I'll hold off on that for right now. Okay? So those are like how you factor things. Okay, that's how you can factor stuff. Now, Ikeva had a question, and sometimes the idea is like, we can't always figure out what all the numbers are that divide up another number, okay? So the kind of a way you can do that, well, actually, this is still kind of tricky to do it this way, but yeah, one thing that can help us in this is using a factor tree, if you guys remember that. So let's say we want to factor, okay.
I was good at it, but I hated it.
Yeah, it's not the not the greatest thing in the world, but let's take a look at it here. So let's say we want to factor the number 36. Okay. Into primes. So we're going to factor 36 into just prime numbers.
What's prime, like 1?
Yeah, numbers that are, well, so Haley was talking about them earlier. Prime numbers are numbers that are only divisible by itself and 1. So like they don't break down anymore, if you think about it that way, right? So for example, 36 then, okay, we're going to use a factor tree.
How far do primes go up?
So primes, like what's the highest prime there is? So it's believed, we don't know the answer to that, it's believed that primes go on forever, but they're very hard to find. They can be very hard to find. The higher you go, it's harder to find because, there's so many numbers that could potentially divide them. And in fact, this is a true story, the way, when you go online and you purchase something, right, there's you go to an online store like Amazon or something like that, and they have this stuff called encryption that helps to secure your data so that you have, you send data to Amazon, then confirms that data with you, but if people were to intercept that data, they aren't able to then steal your credit card easily and stuff like that. And they use prime numbers to actually make it really hard for people to steal your identity and stuff like that when you do purchases online. That's how they secure things, okay? It's a little bit, obviously it's a little more complicated than that, but prime numbers are a huge important part of that, okay? And cryptography and encoding things. So anyway, we're going to just break down into some basic primes here, though. So we're going to start with 36, and basically you just start with just picking any number that divides 36. So,
6.
okay, yeah, so 6 and 6. One easy way to see this, so there's kind of two rules here to help you think of things. So even numbers
Well, what's 36?
are divisible by 2. So that's one kind of rule that can help you. Let's see. If the sum of the digits, so that's one trick to help you. If the sum of the digits,
The sum of the digits.
so example, what would the sum of the digits here be?
6.
3 plus 6, which is what? 9. So 3 plus 6 is 9. Is 9 divisible by 3? 9 is divisible by 3, so 36 will also be divisible by 3. So if the sum of the digits of the number is divisible by 3, okay, is divisible by 3, then the number is divisible by 3. It's harder to write out than it is to actually just to do.
Do we have to do that?
It's helpful just because that way it's less guessing and checking. I can look here and see, let's see, 3 plus 6 is 9, 9 is divisible by 3, so 36 will divide by 3. So I know that I can break it down into 3 and something else.
I thought you just got 3 and 6 by random and connected.
Oh, yeah, sorry, no. I'm talking about this one, yeah. Okay, other things, right? If it ends in a 0, what is it divisible by? 5 actually is one of them, but I'm also thinking 10, right? Okay. And then if the number ends in a 5, it's divisible by 5. So those are some things just to kind of help you. Okay. But of course, you don't need to remember any of those rules because you all have calculators available to you, and you can just kind of guess and check. But this will help you guess smartly, right? You want to be good guessers, not just random guessers. Okay. All right. So with all those little tricks there that we have, and there's other tricks too, but these I feel like are the easiest ones to remember. There's actually like a trick for like if it's divisible by 4 and other stuff, but I'm not going to worry about those. We'll just worry about these. So anyway, so 36, we already said it breaks down into 6 and 6. So we'll break it down like this. Make a little, kind of break it up. Make a little V. Okay, like a tree diagram kind of thing. And then we ask ourselves now, okay, 36, that's 6 and 6. Does 6 break down any further? Yeah. Okay, 3 and 2. So I can break that down into 3 and 2. Does this 3 break down any further? No. So I'm going to circle that because it's done. What about 2? No. Okay, and then 6, does that break down? Yeah, we just said 3 and 2, right? Okay. That's right, we could have broken it down by 9 and 4 if we wanted to, and then break it further that way too. So we're now done. We know we're done factoring this 36 because we only have primes left. Okay, and so what this means is that 36 is equal to 2 times 2 times 3 times 3.
But you could easily say 2 times 3 times 2 times 3.
Right, we put them in order though, but yeah, and I'll just show it to you here real quick. 2 times 2 times 3 times 3, 36. Ah, great. So yeah, so Chardez realized here that when we have repeated multiplication, we could call that 2 squared times 3 squared if we wanted to. Same thing. Yep. Very good. Remember, we used this factor tree when we were talking about simplifying square roots. When we were simplifying square roots, what did we look for in our factor tree? Do you guys remember? When we were doing square roots and we wanted to simplify square roots, we were looking for pairs of numbers, pairs. So for example, we have a pair of 3s and a pair of 2s, and so that 3 and 2 would go outside the square root and become just a 3 and a 2, and actually would yield 6. So the square root of 36 is actually just 6. Anyway, that's what it is. Okay? So that's factoring it. All right, I'm going to give you guys an opportunity here. So why don't you guys go ahead and let's have you factor 56 into primes. Okay, use a factor tree. So go ahead and just do that real quick. Go ahead and factor 56 into primes. Use a factor tree. Okay, and again, use your little tricks there. 56 I see is even, so what should we be able to do? Okay, 5 plus 6 is 11, so it's not divisible by, so on and so forth. I'll come and take a look in just a second here. I do. I'll get those to you at the end of towards the end of class when we're working on class break stuff. Not yet. No, not in Pinnacle yet. But they are graded though. Okay.
And then are we just learning factoring?
Oh, today?
Because I know the greatest common factor. What is that?
Yeah, we're going to talk about that in a second here. After this, we're going to move on to that.
Questions on any of this stuff? Yep, that's right. So then I would write 56 equals, and then this, what times what times what times what? All your primes, multiply them. Yeah. Yep. It is. I see that now. Interesting. Yeah. You can write it that way. Absolutely.
Wait, how do I write this one?
Look at all your circles. So circle the ones that don't go any further.
Yeah, but how about the ones that...
So then that's what you write out. So multiply.
Can I put 7 times 2?
Or you can break down.
Can I put 7 times 2?
Absolutely. Very good. Great.
Isn't it 2 points?
2 times 2. Yeah. 4 is 2 times 2. Yeah. Okay.
Minus 7.
So there is what we should have gotten, or something like that. You might have broken yours down differently. Maybe you did, like 56 breaks down into, 2 times 28, and then you broke the 28 down further. That's fine. But regardless of the path you choose in this case, in this specific, in these kind of cases with primes, okay, as long as you're continually dividing by numbers that you can, you'll end up with the same situation here. So 56 is equal to then 2 times 2 times 2 times 7. But then some people saw that we were repeatedly multiplying by 2's here, and so how can I rewrite 2 times 2 times 2?
2 cubed.
2 to the 3, or 2 cubed, exactly right. So then 56 is 2 cubed times 7. Okay, now.
So that's how we're factoring.
Well, this is a way to, this is called the prime factorization. Prime because we're breaking this up into prime numbers. But you'll notice up here, Jason, that I talked about factors, and for example, 6 is a factor of 12. It divides 12 evenly, but it's not prime. So this is called the prime factorization. Okay, but they're still talking about numbers that divide 56 evenly. Now, why did I go through all that? So here's what we're going to do. Now what we're looking for, okay, is something like, okay, we want to factor the greatest common factor from each, expression, I guess.
Is this what our next test is going to be?
Our quiz is going to have it. We're not going to have any more tests. No, we'll have another quiz, though.
Okay.
Quiz on Friday. And it'll be course notes. You can use that and stuff. Okay, so, and here we'll start with this one.
Isn't the greatest common factor out of your expression, like your highest number?
Highest number, and then also like highest variable power too, or I guess the biggest variable that you can pull out in common. Okay, so greatest common factor. Greatest means like kind of the biggest thing, but common means it's the biggest thing that's also shared by the factors. So 14xy and the 7x squared, okay? I wrote those specifically for this first problem because we already talked about these two things, didn't we? We actually listed out all the factors of 14xy and 7x squared. Now there's quite a list here, okay? But what's the biggest thing that you see in common? Or what's actually, before we talk about that, what's just something? What's one factor that's in common to both of these lists? So for example, yeah, I see a 7. They both have 7s. So in this problem, I could pull out a 7, okay? And so let me divide out a 7 here. So if I take a 7 out of 14xy, let me pull that out. Okay? When I say pull that out, we're really dividing it out. So if I divide a 7 from 14xy, what's left? 2, because 14 divided by 7 is 2, so 2xy. Okay? And then if I divide a 7 from 7x squared, what's left? 1x, or just 1x squared, or just x squared if you want to write that. Okay? Now, if you look at what's left over, here, is there anything else that's still in common between these two things? Okay, so they both have an x in common, right? This is x squared, but this one's just an x. So the biggest thing we can pull out of both those is an x. We can divide an x out. I'm going to take an x out of this, so now I'm going to pull that x out front. 7x. Because, no, actually, it's not because of that, because I only have an x in this term. Not x squared, just x. So the biggest thing I can pull out of here is an x, and so even though, yes, I have an x squared here, since I'm limited by this x, so I can only pull that out. It's the only thing in common. Okay, but what's left here then? If I divide an x out of this, what's left?
Wait, but if you do 7x, wouldn't that make 1x squared, 1x cubed?
Well, careful, we're dividing. So x squared would actually go down to just x, just an x, or 1x. Right? You follow that okay?
Yeah.
Okay. And then what, if I divide an x out of here, what's left?
1.
Okay, a 1 from the x, but what's left over still? The 2 and the y are still left there. So I divided that out, and there's what it is. Okay, so Where'd I lose you? Did you get this step from here to here?
No, that's what I'm missing.
Okay, so basically, Jaden, when it came to this problem, I looked at this and I said, I want to find the greatest common factor, but in order to do that, we can really just find any factor first. So we just look at this and see, both of these are divisible by 7, right? 14 divided by 7, 7 divided by 7, and so if I factor out that 7, if I divide it out, I'm left with a 7, I can pull that 7 out front.
So you would be.
And then what's 14 divided by 7? 2, and then the xy is still there. We didn't touch that, right? And then 7 divided by 7 is 1, and I still have the x squared there. Following so far? But I want the greatest common factor. So now I still want to see, is there anything I can divide these two things by? Well, they both have an x. So I can divide an x out of this, leaving 2y, and the x goes out front still, 2y. And I can divide an x out of this. X squared then would be just x if I divide an x there.
Okay.
So 7x.
You wouldn't distribute at all.
So, right, in this case, we're kind of going in reverse.
I just want to see that.
You want to multiply it through.
Yeah.
I understand what you're saying. So, yes, if the directions say, like, you know, distribute and combine like terms, you then distribute. Here it says factor, so we're going backwards. Distribute, you multiply. Factor, you divide. So we're going backwards here. Okay, that's the idea. I know, I understand. Like, you're looking at this like, okay, now we're going to do the arrows, and we're back to right when we started, right? So that is, but Jaden actually has a good point. You could, if you wanted to check your work, then redistribute this to see if you do end up back with this. And then you would see that you got it right. Okay? Because that is the idea here. This thing is equal to this thing. They are equal. Okay? Now, is there anything else I could divide both of these by? Evenly. Yeah, and the answer is no. Okay? So we factored out the greatest common factor. That's it. Okay, the greatest common factor was 7x, and then that's what we're left with there. The 2y plus 1x in the parentheses. Okay? Now, that's a way you can do the greatest common factor. Now, let me go back up here real quick. Can I scoot up? Okay, let me go back up here. Let's look at our factor list here. Okay, we said that we saw that 7, they had a 7 in common. They both have 1s in common. Okay, let's see, they were both divisible by x. Okay, they're both divisible by 7x. Where is the 7x? I didn't list 7x up here. Whoops, 7x should be there too.
The 7y should be up there.
So then 7y should be up there too. Okay, but if you look here, of the things that they have in common, so they both have a 7 in common. They both have 7x in common. They both have x in common. And they both have a 1 in common. Which of these things are the biggest thing, though? The biggest thing is 7x. It's the biggest. Okay? It's the most that we can divide out. They both have a 7x in common. So that's the idea. Okay? So you don't have to factor out the GCF all at once, the greatest common factor all at once. You can factor out common factors until you see there's nothing left to factor out. Yes?
So what if you divided 7xy and 14xy? What would be your biggest factor? 7x or 7x or 7y?
All right, so let's take a look at that real quick here. So this is Kayla's question, right? 7xy plus 14xy, right? Okay, so let's see that one. Let's just change it ever so slightly. Okay, so can someone tell me what's something that we can divide both of these terms by? Okay, it's 7. So if I divide out a 7, what's left from this one? xy. What's left from this one? A xy. Okay, now, we're not done yet, though. We have to check to make sure. Did I divide? Is there anything else I could divide in common between these two? They both have an x and a y, so I could pull the xy out front.
So you could easily do 7x and then do...
Absolutely, yes. You don't have to do it one step at a time. If you see more than one thing, Kayla, pull that all out. The only thing is, the more you pull out, then the more chance you potentially could make a mistake. So that's why sometimes I like to do it step by step. But this is fine. Okay, if I divide an xy from xy, what's left? 1. Good, we're dividing. So when you divide something by itself, you're left with a 1. Okay. What about 2xy? What's left? 2. And so you get 3. And then 1 plus 2 is 3. Ooh, but what can I do with that 3? What can I multiply that with? The 7. Okay, what's 7 times 3? 21xy. So in this case, it kind of simplified down to just one thing.
No, you couldn't.
It's all multiplication here, Jade.
Sometimes you say you can't do that. Then you say you can.
Okay, understand. So what's the operation? It's all multiplication, right? And so you just multiply that stuff together. Now, Jaden, you're right. It is confusing. It's not easy. I'm not trying to say that it's not easy, okay? It can get confusing, but This is true. Now, we actually could have figured this out without using greatest common factor here. What's true about 7xy and 14xy? They're what?
Prime. No?
We talked about it. Well, okay, they're both multiple 7. That's true. I guess I'm being too vague in what I'm asking here. Do I need to I can simplify this without factoring. 7xy and 14xy, they're like terms, aren't they? What's 7xy plus 14xy?
Oh, 21.
21xy, which is what we got. Whoa, it's the same thing. Okay, but here's the thing though. Are these like terms? No. So in this case, you have to, factor obviously. But if you see like terms, feel free to add those together first and then factor and stuff. Well, you should have said something, Garrett. That's a good job.
Is there another way you can find GCF? Not that
Yes.
I don't like this way, but I feel like I learned it a different way.
Yes, there is a different way. I will show you that different way, okay? I think this is the better way because I just, you just kind of, it's like a process. You just kind of keep going with it. But yes, I will show you. Yeah. Let me show you maybe something you guys have seen before. All right? And I'll try and do this with like a...
Do you want us to write this down?
Yes, please do write this down. All right. Okay, let's factor. So that's going to be our directions. Factor using GCF. All right. So let's do it the way I just showed you, and then I'll show you the way that maybe you've been taught before, the one that Ikeba thinks she remembers, or kind of remembers, and then because I'm sure some of you guys will like, oh yeah, I remember seeing that and stuff like that. Okay. So let's look at this one. 4x squared plus 8x. Okay. So let's see here. So Kyle, can you tell me here, for 4x squared and 8x, can you tell me something that divides both of those things evenly?
4.
Okay, great. So we can pull a 4 out. So again, I'm doing it our way we just talked about, and then I'll go back to the other way. So we pull out a 4, we're left with x squared plus, let's see here, 8x taking out a 4, what's that left with? 2x, yeah. Okay, did Kyle pull out as much as he possibly could there? No, we still have one more thing we can pull out. Kyle, can you identify something else we could pull out there? What else can we divide out here? Can we factor out? What else is in common here?
2.
X squared does not have a 2. Be careful.
Oh, x.
X, there we go. Yeah, there's an x in common. So we can divide out that x. X squared, taking out an x, what's left? X. 2x, factoring out an x, we're left with what? 2.
Can you add those together?
Can we add x plus 2?
Yeah.
What do you think?
Yeah.
No, we cannot add them together. They're not like terms. This has an x, this one does not have an x.
Okay, then how come sometimes you can add 2 and x and make them 2x, but now you can't?
2 times x is 2x. Or x plus x is 2x. But yeah, x plus 2, no. They're not like terms. Okay, so that's this way. Now, alternatively, yeah, this is it factored out by GCF. That's it. That's the GCF. Because you can't divide anything else out of x and then 2. The greatest common factor is 4x. That is the GCF. Okay, but then that's what's, this is the full thing. Yeah, no, that's good. I'm glad you said that. I wanted to make sure that was a clear point. Now, let me show you an alternative way here. What you do in the alternative, and this is probably what you did back in, like maybe Algebra 1, maybe you saw this, or somewhere else, I don't know. But basically, you use your factor tree. You see that 4 is equal to 2 times 2. Okay, and then 8, that breaks down to like 4 and 2, and then 4 breaks down to 2 and 2.
Wait, so what are you doing?
We're factoring. I'm doing this like an alternative. So this is like method 1, and this is method 2, using prime factorization.
So why aren't you just forgetting the x squared and factor?
Oh, I'm going to get to those in a second. I just wanted to factor the numbers. So 4x squared then, that's equal to, well, 4 is equal to 2 times 2, but then we have x squared, so what should I write after that? X times x. So I'm going to expand out, 4x squared, I'm going to expand it out. You see how I did that? I took 4x squared and expanded it out into its primes, 2 to xx. 4x squared is 2 times 2 times x times x, right? 8x, well, that's going to be 2 times 2 times 2, times what? Times x. Okay? So again, this is a different method if you're unsure about yourself here. This one kind of takes some of the guesswork out. Okay, and if you look here, these are all factors of 4x squared. These are all factors of 8x. I'm looking for the greatest common factor. So do you see any common factors between these two things? Okay, so I see a 2 and a 2. We have any other pairs? Another 2 and 2. Any other pairs? X and X. Okay, so all these pairs, 2, 2, and X, is your greatest common factor. 2 times 2 times X is your greatest common factor.
Where'd you get that from?
Where did I get what from?
2 times 2 times X.
2, 2, and X, the pairs that we found. Okay? 2 times 2 times X. And then what's left over? What did not pair up? Well, from the 4x squared, there was an X. From the 8x, what was left over? A 2.
Where'd you get the X?
They were what was left over. They weren't paired up. They were unpaired. And what's 2 times 2 times X? 4x. And there's X plus 2. And look at that. They're the same thing. Okay?
That's definitely right.
This is the way you want to do it?
No, it's not the way I want
Oh,
to
okay.
do it. It's the way I want to do it.
So that's the way you remember, though? Yeah,
Yeah.
okay. That's what I thought. Yeah, okay. All right. Let's try one more here, and I'm going to get you guys started on your assignment. Okay? Let's try one more. Let's do 3a to the 5th minus 18a to the 4th. And we're going to factor using GCF. Okay, 3a to the 5th minus 18a to the 4th. Okay. Three a to the 5th minus 18a to the 4th. All right, so Xander, 3a to the 5th minus 18a to the 4th. Do you see anything in common between these two? Anything we could divide between these two things right here? Okay, you see an a. How many a's could we divide out? 4 of them, that's right. This has a to the 5th, this is a to the 4th, so there's 4 in common. So we'll say a to the 4th. And then if I divide a to the 4th out of here, what's left? Because he saw that this has a to the 5th, so there's like 5 a's being multiplied together. This is a to the 4th, there's 4 a's being multiplied together. So between the two, it shares 4. There's 4 a's kind of shared. Does that make sense? Okay. So if I divide out a to the 4th from 3a to the 5th, what's left then, Xander? Yeah, so 3a to the 1, or just 3a, minus, and then 18 dividing out an a to the 4th, I'm left with just 18. Okay?
Is it okay if we did it like 3 first?
That's fine. Yep, exactly right. You'll see. So Xander, is there anything else that can divide out between these two things? Anything else that would evenly divide both of these? Yes, there's a 3. Okay, 3a divides by 3, 18 divides by 3. So we factor out the 3, so we're left with 3a to the 4th. 3a divided by 3 is what there, Xander? It's a. Or 1a if you want to put 1a. Minus, and then 18 divided by 3? 6. And so a and 6 do not factor anymore, so that is your final answer. That's factoring out the GCF. And again, the 3a to the 4th, that is the GCF. It's the greatest thing that's in common to both. If you were to redistribute 3a to the 4th to both these terms, you would end up with what we had in the start there, 3a to the 5th minus 18a to the 4th.
What's the story today?
I heard it was possible, yeah. So, Jaden, the key thing here, to know that you're done, is that you cannot divide out any more. So, a minus 6, there's nothing more in common. That's how you know you're done. Not distributing, or combining like terms or anything like that. You know you're done here when you've divided out as much as you can. And no more can be divided out. Okay? Questions on any of that? Okay. If there were 3 terms here, so if it was like 1, 2, 3 things, you look for something that divides all 3 simultaneously. Okay? So anyway, that was that. All right, let me give you guys your assignment then. And I'll pass back the quizzes, yeah.